Hello everyone, I hope you're enjoying Deploy by DigitalOcean. My name is Mason Egger and I am the lead developer advocate at Gretel.ai, and today I'm here to give my talk, I Can't Believe It's Not Real Data, an Introduction to Synthetic Data. So first, let's go ahead and set the stage. Let's imagine some scenarios. So imagine that you're a developer working on a web application that manages students in a classroom. This application might do student grades, it might deal with attendance, it might hold parent contact information. It has a lot of valuable data in it. And as you're working on it, you've come to the point in the process where it's time to test. Hooray! Everyone's favorite part. But you can't really access any of the production data that already exists for, security reasons. We don't just give access to this database to anybody who wants it. One, because it's not safe. Two, there's laws around it. Student data is protected by something called FERPA, which makes it very difficult and illegal for people to be able to access that data. So you end up having to test this database with only a handful of records. Maybe you spin together a couple, thinking these are going to be representative of the problems that you're going to face, not really knowing, but kind of guessing. And because of this, you test and an edge case slips through that just wasn't represented in the test database, and now you have to go back and fix this. And you have bugs and you're fixing it. The software lifecycle continues. This is how software is built today. Let's not pretend that it's efficient, because it's not. If you had had access to that production data or something like that production data, probably would have saved a lot of time and a lot of money. But let's imagine another scenario. So imagine that you're a data scientist and you're trying to build a model. You want to figure out how to predict a rare disease. You have a lot of patient data, so you're going to take this data and you're trying to predict this rare disease. So you start looking for the relevant data sets and you realize you don't have as much as you thought. You don't really have enough for a model to train. Like, the model probably isn't going to be successful just because of the lack of data, but you kind of have to cobble it together and you train it on this limited data set, and the model is unsuccessful. You kind of knew this was going to happen. It's not predicting the disease at all, or very poorly, but you kind of knew this was going to be the case because you don't have access to the data that you need. But wait, someone in another hospital has emailed you and said, hey, I have a data set that will probably help you with this problem. I want to be able to give it to you. And you get really excited for that to almost be immediately not the case, because this data has personally identifiable information in it. So you're unable to share this data between hospitals and such. And basically that idea kind of dies on the vine. So the theme that we saw between these two examples is that data is a scarce resource. Developers, data scientists, machine learning engineers, anyone and everyone has issues when it comes to data. There's a lot of challenges around getting data. More often than not, developers don't have access to usable data. And in the machine learning and data science side of things, this can be a big problem, because as we see, 35% of time is spent in this data gathering stage, much more than any other stage in the process of creating a new machine learning model. And very often this data is inaccessible due to PII, so even if they can get access to this data, they still don't have enough of it to be usable. There's also problems with limited data sets. So maybe you have data, but you just don't have enough of it. So the previous one was, unable to access it due to, due to security reasons. And the other one is you have some, but it's not enough. So you lack quality data that can affect training models or testing anything. And it can be prohibitively expensive or even impossible to collect more, depending on the scenario that you're trying to gather data on. Say it was a comet that was going through Earth's, atmosphere, and well, not through the atmosphere, that would be bad, going past Earth, and this only happens once every 10,000 years, you're probably not going to be able to collect any more data. The next time it happens, you probably won't be here anymore. So you just don't have access to the data that you need. And another problem that is constantly plaguing people who are trying to use data in their work is there's just biased data. Data is very often, or can often be, skewed towards representing subjects in certain areas, and it just leads to improper testing, inaccurate models, and a whole bunch of nastiness. So one of the solutions here that we have for this is synthetic data. So you may be wondering, well, what is synthetic data? Well, synthetic data is artificially annotated information that is generated by computer algorithms or simulations, commonly used as an alternative to real-world data. Now, that's a pretty dense explanation. Let's kind of make it a little bit easier to understand. Synthetic data is created by training a generative machine learning model on your data. So you take your data, you train a model on it, and that model produces more data that is similar to your data. So you may be wondering, well, isn't that just fake data? And the answer is no, not really. Synthetic data is different from fake or mock data. You may be thinking of the Faker library. in Python, fake or mock data is not representative. It is purely random. There is the correlations that happen between the data points inside of real data will not be represented in a fake data set that is just randomly generated. And if it is, that was pure luck and you should not depend on it. And very often, fake data can be too clean. We know, as anyone who's ever worked with data, that data comes in all shapes and forms. We spend a lot of time sanitizing it and making it better, and fake data doesn't really create bad, crummy data. So if your application is trying to test for this, you're not doing yourself any favors because you're removing a process from the testing phase that is going to happen in production. So this often, whenever I use this point, some people often ask, well, does that mean that if I give junk data to a synthetic data generator, it's going to give me junk data out? And the answer is yes, that's its exact point. Synthetic data is meant to give you data that looks like the original data set. The onus is still on you, the developer, the data scientist, to figure out, is this data any good or not? But what synthetic data can do is it can give you a lot more of it and a whole bunch of other really cool things. So we generate synthetic data from this initial data, from our existing data, and it looks and behaves very much like our initial data set, so much so that it can be nearly as representative as that initial data set. So you may be wondering, well, what can I use synthetic data for? Well, synthetic data has a lot of really cool applications, but you can think of it as just an alternative to real-world data. Any task that you need data to perform, you can use synthetic data. You can use it for training models. You can use it for applications and testing purposes. You can use it for creating sample data for demos. We see this a lot with some solutions engineers. You can use it to anonymize data so you can share it between different people and so much more. There's many, many use cases for synthetic data. So you may be wondering, well, how do I use it? What are some of the ways, how can I use it for those purposes? And there's 3 really good examples that I'm going to give you today. The first one is making private data accessible and safely shareable. The second one is generating more samples with limited data sets. And the third one is reducing bias in machine learning data sets. So let's talk about these. The first one I mentioned was making data accessible and shareable. So very often, data contains PII, personally identifiable information, making it very risky or even illegal for developers to work with. Developers and data scientists very often don't want this, okay? Even if they want access to this kind of data, they do not want the PII that comes with it. They are now responsible for it. And as a security standpoint, it's not a good idea to have a lot of people access to customer records and customer data. So you don't want to give it to them. They don't want it. Don't do it. So they can't have access to this data, but with synthetic data, you can generate statistically similar data while removing the PII. You can train a synthetic data model on your production database and generate data that is anonymized and still representative of the entire data set. And if that data set were to get leaked, as long as the correlations between the data was not, say, company secrets or something, it wouldn't matter because there's no PII in it. This allows you to share your data not only within the company, but externally as well. And this is where some of the unlimited potential, I think, kind of taps in. Is like, imagine what we could do if every company could share every single data set that they have without fear of personally identifiable information being leaked. It would be a really interesting world, and we would get so much done. Second use case that I'm going to talk about today is augmenting small data sets. So very often we don't have enough data, especially when it comes to training models, and this is a serious bottleneck. Data is very often your most valuable asset, and collecting data is expensive and it's very difficult. It's probably very expensive and very difficult. It's one of the biggest problems that we face. Synthetic data allows you to generate an unlimited amount of data based on a relatively small data set, though. So imagine you have a machine learning model and a very small amount of data. You can use synthetic data to regularize, that's a hard word for me to say, your model training. And, be able to work with your model. It's really good here because now it kind of gets you past that hump. So you may be at this point where you're trying to debug your model and you don't know if the problems that you're facing are because the model math is incorrect or you don't have enough data, or is the data not accurate? Like, is the data not representative of the problem that we're trying to solve? And whenever you have a small data set, it's really difficult to figure that out. But now you can generate as much as you want, and it lets you check off the list that it's not the data size. It's very similar to the developer problem when you're working on code and you get stuck on a bug and you're trying to debug it for a while and you finally fix it and a new bug pops up and you're still really happy because at least it's not that same bug. With this, you can now use it to be like, okay, well, we know that it's not a data problem. Is my math wrong? Is this data representative? We can now move forward in the process and figure that out because you have enough data. From a testing standpoint, or a DevOps standpoint, this is really interesting to me because you can now load and stress test your application. Imagine being able to generate almost identical or the similar looking data requests to like a web service or a web API that, you know, it's not just random. You're not just using like something like Chaos Monkey and just hitting the API a lot of times. You can actually replay traffic that looks similar to the original traffic. That would be really cool to do here too. And the last thing I'm going to talk about, or this final thing I'm going to talk about, is reducing bias in data sets. This is a really cool one. So as we all know, bias in data sets is a big problem. At the best of times, it just leads to an inaccurate model and people go, oh, that doesn't work. In the worst case of times, it can actually cause physical and mental harm. So we have to take bias very seriously. However, if you can identify the bias in your data, you can then use synthetic data to balance your data set and fix the problem. So there's a really cool blog post here that's in these slides that will be available after this talk that is about reducing AI bias with synthetic data in heart disease prediction models. In this blog and in this model, 68% of the data was male and 32% of the data was female, offsetting a 2-to-1 ratio. That's a pretty biased data set. So using synthetic data, we were able to generate more female patients. We were able to identify which patients were female and generate enough to where we were able to make a 50-50 ratio or a 1-to-1 ratio of data. So that way it was no longer a biased data set. This increased the accuracy of the model in predicting heart disease from 88.5% to 96.7%, increasing also for females, 6.17% more females with heart disease could now be accurately diagnosed. Now you may be looking at that math and going, Mason, 88.5 plus 6.17 does not equal 96.7. And you're right. Not only did the prediction for females go up, but the prediction for males went up as too. It turns out that debiasing data sets helps not only the minority in the data set, but also helps the majority in the data set too. So we really should be debiasing our data sets because you could see improvements on the entire model, not just the minority population within the data set. So, a lot of really cool stuff happening in synthetic data, but you may be wondering, well, is this brand new? Like, I've never heard of this. Where is this being used? And the answer is it's actually being used in a lot of places. It is a relatively new tech, but it's being used in a lot of really cool ways. So, automotive and robotics companies are using this for self-driving cars to be able to create synthetic data for road conditions and such so they can train these models that go with self-driving cars. Gaming in the metaverse is using this to create biometric data. So instead of having to have a whole bunch of people put on an AR headset and then do eye tracking stuff, you can take that data set and then expand upon it and have all of that. Cybersecurity and InfoSec firms are using this to be able to detect rare events, including fraud and cybersecurity. This is the really, really cool one. Healthcare and life sciences are using this to create synthetic genomic data to fuel medical breakthroughs and encourage better medical care. We're able now to, or we're working on synthesizing human genomes to be able to predict diseases. You should definitely check out that blog if that interests you. Manufacturing is using this to simulate complex supply chain operations and predict where failures may occur. Software development and operations are using synthetic data to power pre-production tools like we were talking about with testing, being able to create test environments that are very similar to the production environment and have none of the privacy risks of leaking the data and more. There's just so much that's happening with synthetic data. So you may now be wondering, well, this is really cool, but like, is this new tech? Is this tech going to kind of stick around? What does the future hold for synthetic data? And actually, yes, a lot of people are thinking that synthetic data is here to stay, and it's going to be very, very popular and powerful in the future. By 2030, Gartner predicts that synthetic data will overshadow real AI models. And as we already saw in the previous example where everything was happening, this is already happening today. Not only does it allow for us to be able to just train models and do stuff without having to worry about using production data or just creating more data as we need it, it allows easier compliance under data protection laws such as GDPR and CCPA, and it reduces the attack vector on data. Right now, every single person who has access to your production data is an attack vector to get access into it. But if you can take all of those away and only like 1 or 2 people had access to it and everybody else in the company had to do with synthetic data, then you've reduced the attack vector really, really by a large factor, and now you don't have to worry as much about data breaches. You've reduced an attack surface. And eventually, this is a problem that synthetic data is working on right now, is solving the cold start problem, which is how do you start when you have no data? This is still really cool, and I'm looking forward to see how it's solved. But, just what do we do when you have no data? Where do you start then? So how can you get started using synthetic data today? Well, there's a lot of resources available. There's an open source agenda and an .com tag with synthetic data. There's an awesome synthetic data list that has a lot of different repositories and such in it. You can also look at some open source available options. Gretel Synthetics is the library that the company that I work for, Gretel, bases all of our models on, and these are open source synthetic data models. You can also look at stuff from Synthetic Data Vault. Stable Diffusion is currently really popular in the news right now due to images. But if you want to be able to get started today and you don't have a GPU, maybe just want to try it out, you can try it out for free at Gretel.ai. And you can train synthetic data in as simple as 3 lines of code. And this is really easy with tabular data and time series data. There's all sorts of data that you can create it from. So with any further ado, we're going to do a quick demo here demonstrating how to create synthetic data inside of a Postgres database using Gretel. Okay, so we're going to do a really short demo where we take some data from a DigitalOcean managed Postgres server, and we're going to synthesize some data to create a synthetic data set for it. So what this notebook allows us to do is this notebook allows us to run on any relational data set, not just Postgres, but this works for SQLite, Postgres, or MySQL, anything that SQL Alchemy can run, and then you can generate synthetic data out of those databases. So first, let's talk about the database that we're going to be using. So this is a sample e-commerce database that you can download that we have access to. It's here in our S3 bucket. And it's basically just a simple e-commerce thing with order, inventory, events like what caused the event, where it's going, users, which distribution center, and products, as you can see here. So there's a lot of different keys that go in a lot of different directions. There's a lot of causality and relationships between these tables that we need to maintain whenever we're doing our synthesizing. So the first thing you're going to do is you're going to import this Python package. It's not on PyPI yet. It may be by the time this airs. So it's a multi-table repository that allows you to just install this library that allows us to do our multi-table synthesis. And we've already installed it in a previous runtime, so we're good. Some of this stuff is going to have to be from previous runtimes because this is still, again, training a model, and this takes time, and I have a very limited window to talk to you today. So the next thing we do is we're going to specify our Gretel API key, and what it does is basically we go to our Gretel Synthetics. If you go and just create a free account on Gretel.ai, you'll be brought to this dashboard, and you can get your API key here. You just copy it, you paste it, and this is what's going to log you in directly in. And now, as you see, we have the little green check mark. We are logged into the Gretel API. So the next thing we're going to do is we're going to crawl the database engine. So if you were using, say, the local SQLite copy, you could just wget that down and then change this create engine to use the SQLite, but that's not what we're going to do. We're going to create an engine with our entire string. Yes, my password is in here. This is not the best practice. By the time you're seeing this, this database will be deleted, so you won't be able to access it. But yeah, if you are writing this for production code, I would recommend not leaving your password in plain text. So we're going to go ahead and just crawl this database real quick. And what it's going to do is it's going to connect out and basically pull all of the data out of the database, create CSV files for them, set up the relationships, all of that such. Alternatively, if we didn't want to just let the data do the crawl database, we could specify specifically the table files, like which table is which, what are the primary keys, what are the relationships between them. So this is something that if you want to manually configure this, you can, but we're not going to do this today for the sake of this demo. And this is next is where we're going to enter in the ratio of what we're doing. So this is where if we enter 1, we're going to generate the same amount of synthetic data. 2 is double, 0.5 is half. So we're just going to set this little variable here in the config, and that's going to tell our synthetic data how much of it we want. So we want 2, so we're going to double the size of our synthetic data. So the next thing let's do is let's just look at some of the data, and let's just change this n equal to 10 here. Get 10 records. We're going to do, this is the actual data. This is a join of order items, the order items and users. So we can kind of just see some of the data that's in there. And what we have here is our output of our table. So this is the actual data from our database that is now stored in these files, and now you can see exactly what's going on. We joined them together, and you can see there's 10 records here of different types. So the next thing we're going to do is we're going to set up our training config. So our config is currently stored as a YAML file in this GitHub repository. You basically just download it and load it. If you did want to be able to modify it, you could. If you click here, we can see more about the different files that we have, how we want to do this. This one, I believe, was using the default YAML file. So these are our hyperparameters, which you can easily tune. So if you don't want to use the default, feel free to change it yourself. But we do put a lot of effort in trying to make sure that our default parameters are good. So the goal is for you not to need to be able to tune these, but if you're doing really advanced things, you will probably need to be able to tune them. And then we set our distribution center model here. We're setting some of our privacy filters to none. The higher the privacy filters are, the longer it takes to train. For this instance, we're setting it off. You can totally tweak them any other way you want. And now we're going to create synthetic data. And I'm going to click play on this. And I'm going to come back because this does take a little while to run. This is, again, we are training a machine learning model and doing all of that. So this does take a little bit of time for it to run and synthesize. We'll come back and we'll see it when it's done. And we're back after training our model. Just so you know, this model can take a very long time to train, so just be wary of that. So as you see, we've went through and we basically trained models on every single table that was inside of our database. And then we generated synthetic data items. As you'll see here, we also got a synthetic data quality score, or SQS. We're gonna go over that a little bit here, but basically we are able to tell you how relevant or how accurate the data is to the initial data set. So the first thing we're going to do is we're going to verify the size of our new synthetic tables. So we did it at a ratio of 2 to 0. So original record count 10, 20 for distribution center. For order items, there was 7,882. There's now 15,764. As you see, we have a 2 to 1 ratio of increasing it. So now where our original database, say, only had 7,000 order items, we now have 15,000 order items. So we've now made our database twice the size, which is awesome. And then we'll come down here and we'll look at some of the synthetic data. We'll choose 10 again for our joined data head. And what we'll say is here, the number of records and order items table is 15,764, 4,394 records in the user table, the number of records we joined. So then we just come and we look at it. And as you can see, the data looks almost identical to, let's click this magic little button here so we can scroll, looks almost identical to the original data set. So we have not, this is all synthetic data, by the way. This is brand new data for us that we can use for anything we want, for testing, for training, for, I don't know, for setting up sample applications. Anything you want, you can use this for. So yeah, we made synthetic data from a relational database, and we were still able to perform joins on it. We were able to maintain our relationships and the primary key relationships between the data. So fantastic. And now the last thing we're going to talk about really quick is the synthetic performance report. So Gretel has a synthetic performance report or synthetic data quality score that we can kind of show you on how accurate we believe your data is to the initial data set, how representative. And you can learn more about them by reading these blogs here. But if we go ahead and click play here, we'll go ahead and just use the HTML display and download the new one. And we're going to currently download the users table. So this is for we can do it for any of the individual tables. So we have a synthetic quality score of 86 and a privacy protection of very good. So our field correlation stability was an 89. Our deep structure stability was a 75. The cool thing about these scores is you can click on all these information bubbles and they'll tell you exactly what they are and how we calculate them. So yeah, that is synthetic data being generated from a Postgres database using Gretel. And that's all the time I have for today. Thank you so much for attending my talk. I hope you really enjoyed it. I hope you enjoy the rest of DigitalOcean's Deploy conference. If you would like some free swag, including this really cool sticker here that I like and that I helped make, I like bad puns. You may have a bad pun sticker. Either go to grtl.ai, that's our bit.ly link, /deploy2022, or scan this QR code and fill out the form. Basically, give us your email address. We will send you a link to be able to redeem some swag and get this sticker pack. This form will close a week after the premiere of this talk, so you have until a week after today. That's all I have for this time. Thank you so much for listening. Follow me on Twitter. If you have any questions, you can always tweet at me there. I will be in the chat today, so feel free to message me there. Follow Gretel on Twitter to be able to just keep up with all things that are happening in synthetic data. If you want to ask questions inside of a Discord or inside of a community, you can join our new synthetic data Discord channel, which will allow us to be able to just chat about synthetic data. You can get started going to Gretel.ai, and you can use this QR code or the link that you see there, grtl.ai/deploy2022/slides, to be able to access all of these slides, because I know there's a lot of links in here that link to a lot of really cool blog posts and examples. Feel free to go ahead and grab those, and I hope you enjoy it. I hope you get to try out synthetic data. It's a really cool tool, and I think it's definitely going to help make your life a whole lot easier, and it's going to help alleviate a lot of your data woes. Thank you again for attending Deploy by DigitalOcean. As an ex-DigitalOcean employee, it's great to be back. Thank you for having me back, DigitalOcean, and I can't wait to see you next time. Have a good day.